Can you see my screen?
Yes, sir.
Okay, welcome. Today we're going to be looking at chemistry and we're going to be looking at separation techniques. Very, very importantly, you're going to be seeing mixtures every time, and you need to know the right separation technique to apply to a given mixture in order to get the components separated. Now, you want to eat rice, you go and buy the Nigerian made rice. Is most likely that you're going to see stones inside the rice. So how will you be able to separate the stones from the rice so that when you cook your food and you start eating your rice, you will not start biting stone? How do you do that? So you need to know the rice separation technique to apply to a mixture of rice and stone. That is one. Now if you have your sugar or your salt dissolved in water. Let's say you kept your salt outside and rain fell. You did not know when rain was falling and rain fell into the salt. Now you got back to the house and you want to get the salt separated from the water. You need to know the right separation technique to apply in order to get the salt out of the water. So those are the things that we're going to be learning today, because different kinds of mixtures can be separated with different kinds of separation techniques. Okay, so when you're asked what are separation techniques are simply the way that you can use in separating the components of a mixture into their various constituents. Okay, and the various examples of separation techniques available includes hand picking, threshing, winnowing, sieving, evaporation, distillation, filtration, sedimentation, separation funnel, and magnetic separation, as well as chromatography. So we're going to be looking at these various separation techniques, and we will know the kind of mixtures that we need to separate with them. Now, very importantly, the learning outcome for today is that after today's class, I'm going to be asking you guys to define separation technique for me. That is number one. Then number two, you're going to list the separation techniques that are available and tell me the kinds of mixtures that can be separated with such separation techniques. Okay, so you can see the resources I'm using to teach today. So it says that most of the time the substances we see around us are not in their pure form. So most things you see around you are not in their pure form. You need to conduct separation in order to get the pure form. When you have your rice is always contaminated with stone because you get your rice from the farm. So in the process of processing your rice and getting it, it's most likely that the rice is contaminated with stone. So it's no longer in the pure form of being only rice. So you need to apply a separation technique to the mixture of rice and stone in order to get your pure rice. So most things you see are basically mixture of two or more substances. Interestingly, mixtures tend to also come in different forms. Therefore, there are several types of separation techniques that are used in segregating a mixture of substances. So there are various types. So we're going to look at them. So number one is hand picking. So where can you apply the separation technique known as hand picking? Where can you use hand picking? So you can see this is a typical example. This method involves simply picking out all the unwanted substances by hand. So in hand picking, you use hand to pick out unwanted substances and separating them from useful ones. The separated substances may be impurity that has to be thrown away. So this is a typical example of when you want to separate your beans from stone or your rice from stone. So you use hand picking. Victoria, I hope that is clear. Can you hear me?
Yes,
Okay.
sir.
Yeah, okay. So that is hand picking. So the next one we have is threshing. This one is not actually one of the one of the methods of separation like we see in chemistry textbook, but it's very, very important because we can also use them in harvesting crops. In this type of separation is actually when one of the constituents that you need is actually attached to a stock, like you have your grain attached to your a stock, that's when you can use this to. It's normally used for grain separation. This as well, but I want to get straight to the chemistry part of it. So the second one that I'm going to be looking at is sieving. So sieving is done to separate mixtures that contain substances mostly of different size. So you use sieving to separate substances of different size. The mixture is passed through the pores of a sieve. Then all smaller substances pass through it easily, while the bigger ones don't pass. So a typical example of sieving is when you're processing your gari. So at some point you have to sieve. When you're processing, when you just have a mixture of something that cannot pass through the filter paper and water. So once you pour the combination of water and that very thing, you're going to find out that water is going to pass through the sieve, which is the filter paper, and what the other thing is going to be left on top of the sieve. So that is a typical example of how you can do that. So you can actually use it to get some impure substances out of water, since water is definitely going to pass through the sieve. So sieving is very, very important. You can see the grammatic explanation of sieving. So very, very important. So JAMB is going to ask you, which of the following methods is going to be used to separate a mixture of beans and stone? Beans and stone. Beans and stone can easily be separated using hand picking. Why? Because you can easily differentiate by the color of the beans from that of the stone. You can feel them, so you can easily use your hand and pick them out. Now, if you're asked, which of the following can be used to separate water from sand? You can see that sieving can do that, because the sand will remain on the filter paper of the sieve, whereas the water will go through the sieve. Okay, so let's go on. Let's look at evaporation. So what is evaporation? Evaporation is a technique that is used in separating a mixture, usually a solution of solvent and soluble solid. So when you have two things that are soluble, like the example that I gave you about your salt, if you leave your salt outside and you come back and you find out that rain have gotten into your salt is soluble, and is soluble inside the solvent known as the water. So if you want to get your salt out of the water, you have to use evaporation, and it's very simple. Just spread the mixture of the water and the salt under the sun. The sun is going to help the water to evaporate, and your salt will be remaining. So that is very, very important. So JAMB is going to ask you, which of the following is the method of separating salt from water? Then they are going to give you hand picking, they are going to give you sieving, and they are going to give you evaporation and distillation. You should know that the answer is evaporation. So that is how the question normally comes. So let's look at the fourth separation technique, distillation. So when mixtures consist of two or more pure liquids, so we'll call this one liquid, two or more pure liquids. That's what you use distillation to separate. So you use distillation for such. Here, the components of the liquid mixtures are vaporized, condensed, and then isolated. The mixture is heated, and the component which is volatile vaporizes first. Then the vapor moves through a condenser and is collected as liquid. So distillation is very, very important when you have two liquids that are very, very miscible, but they have different boiling points. So once you heat them, you can see the diagram here. You have two liquids that are totally miscible. They are inside this place. So you heat them. The one with lower boiling point will go out first. So once it's going out, this condenser is condensing it back to liquid and you're collecting it out. Whereas the one with higher boiling point will remain inside this very big one. So all the ones with lower boiling point, they go out. You collect them here. The ones with a higher boiling point stays back, so you can have that separation done. So this is done for miscible liquid. There is an advanced way of doing distillation known as fractional distillation. In that case, You have miscible liquids, but then their boiling points are very close to each other, and that is what you use for crude oil separation. In crude oil refinery, they use fractional distillation. So in normal distillation, you have their boiling points; they are very far apart. But when you have miscible liquid that have very close boiling points, you have to use fractional distillation. Okay. Then filtration, very very important. We have talked about filtration, which you also use when you're sieving, something like sieving. But in sieving, you have solids that you sieve, whereas in filtration, you have a liquid, then a solid. So you have one insoluble solid and a liquid. So typical example is when you're filtering water through the filter paper. Okay. Then sedimentation is when you just leave the liquid and you have the particles with bigger density, they get down, whereas the ones with smaller density stay up. So that you can now you can simply take out the upper one and leave the lower one. That is sedimentation. So you can use it for mud water. You want to separate the mud from the water. So you can see the explanations that are given by the, what's it called, the diagrams. They are very very descriptive. Now we'll talk about separating funnel. In separating funnel, you use it to separate immiscible liquids. That means liquids that cannot be mixed together. Very good example is when you mix kerosene and water. Two of them can never mix together. So the kerosene with lower density is going to stay up, whereas water with higher density will stay down. So that from the stopcock here, you can easily get down your water. Whereas once the water is done going out, you just lock it up and use another container to take your kerosene. So if JAMB asks you, which of the following is the separation technique that can be used to separate two immiscible liquids like kerosene and water? You should know that it is separating funnel. Okay. Then we have magnetic separation. This one is very very simple. Whenever you want to separate something that is magnetic from a non-magnetic substance, then you're going to use magnetic separation. Now, when one substance in the mixture has some magnetic property, then method, this method is quite useful. So whenever you want to separate things like that has iron in them, you can use magnetic separation, because iron can be magnetized. So let's say you want to separate iron from stone. You know that stone is not magnetic, but iron is magnetic. So the magnet is going to take the iron, and leave the stone for you. That's separation. So those are the various separation techniques that we have. And the assignment for today will be to list 6 separation techniques and give me examples of the various substances that they can be used to separate. 6 examples of separation techniques and examples of substances that they can be used to separate. So when you list, say, distillation, you tell us what distillation is and the kind of mixture that you can use distillation to separate. Okay, that's where we're going to be stopping. Like I said before, submit the assignment by writing on your paper, snapping, and sending to my WhatsApp. Thank you. See you when I see you.